Welcome back. After this very short introduction video, let's have a look into this AES crypto function. Let's see how we can deal with unknown Smiley syntax. For example, this try and catch block. Let's see how it looks like and let's see if we are really able to understand it. Therefore, let's go. Let's decompile this app and then get it back on the graphic tablet. So, first we decompile this application. I still got it open over here. APK tool D, AES APK. Alright, and then let's open these Smiley classes too with Visual Studio Code. We trust this author and then com, app hacking, AES crypto. Alright, and here we enable Java. Perfect. Okay, so here we go. We've got our class AES crypto. We are not extending a special class. So we are just having JavaLang object as superclass. Okay, this is our source file AES crypto. Here we have our constructor. All right, and here we have now our method encrypt message. Let's see if we encounter something unusual just by looking at this. So we are not reversing it right now. Let's see. We scroll down. Oh, okay. I guess we have found it. And this one seems to be new, right? So we've got move result to object v4. This is pretty known to us. But then we've got this try and then we've got this part over here. All right, this looks absolutely ridiculous. And then we also got some catch clause over here. We can see exceptions. These one over here look new, but they are in a recognizable format. So this one over here, it's just an invoke virtual method. It's just invoking a public method, print stack trace. All right, and then we've got a bunch of other stuff. This sounds different than the things we have seen so far, especially this one over here. And therefore I would suggest let's take this on the graphic tablet and let's see if we can understand what's going on over here. Alrighty? Okay, perfect. I will see you in just a moment. Okay, so here we are back at the graphic tablet and we have already seen that this file is massive. If we scroll down a little bit, we can see we've got 147 line numbers in there. So at a point we have to reverse engineer this, but not the whole file. We have to figure out, for example, how to print out the secret key, the initialization vector and things like this. In this part, which is the second part, we only focus on reverse engineering those necessary parts. But if you are absolutely insane and you want me to go through this whole file line by line, then simply just drop me a message. For me, it's perfectly fine. But I guess you don't want to watch right now 40 minutes me reverse engineering this. Let's focus on the new stuff. And this is the try catch stuff. This one in the middle over here. So this is something we haven't encountered so far, but we understand the core concepts of Smiley. And these are enough to understand everything right now, even this part over here. You don't believe it? Then let me prove this to be a correct statement. So therefore, let's have a look into this one. Okay, so we want to analyze this part right now. Let's see. In this one over here, we know what this one is. It's simply just a label. We've got a label try underscore and underscore 0. So let's write this down. Try underscore and underscore 0. This one is a label. Label means, or we have seen some labels before regarding to jump instruction. In our if statement, we've gotten condition 0, for example. If the if statement has been true, we jump to this condition. Otherwise, we move on. But we have also seen labels regarding to goto instruction. For example, goto condition 1. All right, nothing new so far. Okay, so this try and might be simply just a label. Let's see how often it occurs. So let's search for this one over here and we can see 2 out of 6 and let's scroll down. So this one appears over here and also here. So within this strange looking syntax over here. Let's see. Yes, so these are the only occurrence of try and end. All right, that's good. This is compact and it's clean. So therefore, let's go deeper into this one. Okay, this one is our label. Let's see. And then at the beginning, we've got this dot catch. We don't know what dot catch is or dot catch does, but we know what this one over here is, this capital L. And then we've got a class reference, and this class reference is no such algorithmus exception. Here we've got no such padding exception, and here we've got invalid key exception. So these are all our exceptions from the Java side. If you remember this, maybe let's clean this up because it's barely not readable. And there we go. So these are simply just our exceptions that we can throw. All right? Okay. We do not know more about this. These are just class references. We've got no clue. Is this now a return type? Is this a parameter? Is this something else? We don't know this. Okay. Then let's ignore this part over here. So this one will be ignored. And this one also, let's see. And then we've got this try start. Try start underscore 0. And we can see once again, this is just a label. Try underscore start underscore 0. Then we've got this strange looking dot dot. No clue what this one is, but afterwards we've got another label, or this already familiar label, try and, this one over here. So here we have our try and underscore 0 label. Barely not readable, but there stands try and underscore 0. Okay? Okay, so I mean, we do not need an 200 IQ to solve this. We've got an start and we've got an end. So this is some range given over here. And let's call these dots simply range. I'm not sure what's the term for this one and if this is even correct. But we got a beginning and we've got some stuff and we got an end. Okay? So let's see where try start occurs in our code, because this is a label we haven't looked up so far. We already know try end is over here. So let's search for try start. Over here, 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 and here. And oh, that's interesting. We've got encrypt message. Then we've got our plain text. We've got v0. And here we've got a try start label. So this one over here, this is our try start label. So could it be that simple that we've got this try start label, then we've got our dot dot. Maybe let's make this green. There we go. Dot dot, and then we've got our try end underscore 0. So could it be simple as this, that we've got our start over here, this one, this is our start. Then we've got a lot of dots until we came to this one over here, the try end. Let's say down there, there's somewhere this try underscore and underscore 0 label. So is this simply just the try and catch block? Let's find this out. So let's clean this up. Okay, line 25, we've got our try start. And over here, we've got our try end. So this one is the start. Here we have our end. And everything in between there is within our try block. Try. And then the end. This would mean after this try block, we have this catch block. And this catch block has now certain conditions. And we can see those conditions already occurring here. So therefore, let's get back to the Java code and verify if our try block starts or includes, let's see, yeah, this key generation. So this one at least. It's hard to tell if this one is already included because it's Smiley and Smiley has disassembled it into certain parts. This one over here, I mean, it's just a label. This one over here, I mean, it's just in reference to a variable name. There cannot go something wrong regarding to this one. Our error could occur in here. This is where we could have an error. So therefore, my suggestion would be that our try and catch block, the first instruction is our key generator, get instance. Okay, so therefore, let's find out if our try block directly starts with a key generator. This one over here. All right? Okay, and therefore we open a new terminal, we go into apps, one challenge to recap all, and we are opening AES APK with JDX GUI. Okay, and then we go into COM, app hacking, AES, and then AES crypto. And this is absolutely correct. Our first instruction in here is the key generator. So this is exactly what our try block looks like. So we've got our try and we've got it over here. We can also see that our last instruction in our try block is the get initialization vector method, this one over here. Then we are moving the result into v4 and then we have our try end block. So if we go into this one back again, we can see, yes, we can see get initialization vector is pretty close to be the last instruction. I mean, afterwards we simply just have a return out of this one. But regarding to the try and catch block, the return type, this one over here, is not being included in this block over here. So in the Java world, once again, we can see return is also included in the try and catch block, but technically correct, it isn't. Because we can see over here, the result would be moved into the register v4, but if we return out of this function, let's see where we return out. In this one, do we have another return? So let's search for return. Yes. Here we can see we have this return object v3. So this is from our get initialization vector, move result into object v4. Then we've got our try end block. And here we can see we are returning out. Sorry for the interruption over here, but there's a slight mistake regarding to the return value over here. And I definitely want to clarify this. I mean, the code, everything we have discussed so far is absolutely correct. But I have mixed it up in the last 2 minutes. So let's get through this over here. We can see on the line number 65, we've got this method invoke virtual, JavaX, CryptoCypher, get initialization vector. This method is returning back a byte array, and this byte array will be stored in the register v4. So we move the result object into v4. And then we've got our try end block, we've got all these catch instruction, and then on line 78, we've got this local v4, which will be assigned this label, this initialization vector label. But then we've got return object v3. This is the line number 79. And if we take a look at what v3 is, we can find this in line 59. So there we have invoke virtual, JavaX CryptoCypher, do final. We have a parameter and byte array, and we also have a return type or return value as a byte array. We move the result of this function cypher do final into v3, and then we are returning back v3. I guess I have said we are returning back v4, which is not correct. We are returning back v3, which is the byte array from the method do final. The rest is absolutely perfect fine, and now we can move on with this one over here. So let's go. So technically, it's not 100% correct. This is not included in our try and catch block, but we can only see this if we enter the matrix. So if we have a look into Smiley, over here it looks like the return type is the return instruction is also included, but that's not true. Okay, nevertheless, we don't want to be that picky. We are super excited that we can understand try and catch blocks already. The last thing we haven't talked about so far is this one over here, this catch block. So here we can see we've got catch, then we've got Java security no exception, no such algorithmus exception, very hard to pronounce. Okay, and then we've got 1, 2, 3, 4, 5 exceptions. Let's have a look into the Java code. Okay, catch, we've got 1, 2, 3, 4, 5. These are all these exceptions over here. All right, so this perfectly matches with this one over here. Back into this one. So what else do we have here? Because we are not done right now. And let's get back to the graphic tablet. Okay, so now we know we've got something like try. We've got a bunch of stuff. And then we've got this catch, which includes those exceptions. And this one also have some code in there. So we've got a lot of catch instructions over here. Okay, so this means this one over here seems to be this part. Okay, so we can understand this part. And this one over here, I mean, no such algorithmus exception. It's our parameter. So let's call this to be a parameter. This might not be technically correct. So even if it's not fully technically correct, I mean, it is what it is. We are providing an exception to this catch clause over here. So we are listening for this exception. And this one it's the exception that gets triggered, and this is the parameter in our catch clause. All right? Okay. And then finally, there's only one thing left. So after this one and this one, maybe let's do it this way. And then we've got this label at the end, which might be overlooked. So therefore, let's make it yellow. So here we have now another label. And this one, for example, this one is catch4. Catch_4. So let's see where this label occurs in our program code over here. Let's copy this, insert it over here. And here we have it. And we have it only twice in here. Yes. So this one, for example, no such algorithmus exception. This one over here, that's a label. And this one over here appears here. So we know that if we go back, can we have both? Then let's maybe take another one which might be closer. Oh, this was a mistake by me. Let's see, do we have catch1? Yes, okay. It's a little bit better because it's closer to this one, and now we've got the full picture. So we've got here our label. Now we've got catch1. And we can think of this like an if statement. It is technically definitely not correct, but let me explain it to you what I mean over here. So let's say we've got something like if we are having, for example, block size exception. This one over here. BS exception. Jump to label catch1. And catch1 is over here. So here we can see this line is the end of this variable. So do not get confused by this one. So we are jumping into this one, catch1. Then we've got move exception into v1. Okay, so now we are moving this exception maybe into v1. So v1 is now bs accept. Okay. And then we've got v1 is being assigned to this variable e. So we've got this exception. Maybe let's write that out. Yes, I've taken, I guess, the longest name. So there we go. Illegal. So this is now being assigned to v1. v1 is now this variable name e. And here we can see we are invoking a virtual method. This one, print stack trace. So we are invoking the virtual method print stack trace on v1, which is e, which means we are calling e dot, oops, sorry, wrong color. This method has no parameters and it's returning back void. And this is all we are doing right now. So, I mean, this if is definitely not technically correct, but you can think of this term. Nevertheless, I would like to remove it over here. So when we have an exception, let's call it not if, let's call it a when block, which is, it's now being introduced by me right now into the Smali world. So we are now having a new block, it's the when block. When we have an illegal block size exception between try start and try end, then go to catch1, which is this one over here. This is my complete free interpretation of a try and catch block. I didn't look it up, and therefore these terms might not be 100% technically correct, but it doesn't really matter because we are able to understand everything in here, and we could easily modify every single part in here and also add this part into new applications. And this is all we need. we understand it well enough to modify it in any way we like to have it. All right? Okay, perfect. So let's get back into the application once again. So here we can see illegal block size. It's E4. So these numbers, I'm not sure, they don't have to match. Yes, this is catch 1, and within our exception, it's exception 4. These numbers or these cases doesn't align to them over here. So E4 might not be or hasn't to be the 4th instruction or catch instruction in our block. But we can see we've got this illegal block size exception. We can see this parameter E4 is printing a stack trace. And then, okay, we didn't look further, but we are returning out of this function. So this is how try and catch blocks works. We haven't seen them before and we haven't learned or looked up anything else. Based on our Smiley knowledge, we were able to understand this complete new block over here, this one, which is absolutely amazing in my opinion. So maybe to finish this over here, let's do this return type also. Let's get back into our exception, which was catch 1 over here. So here we have seen print stack trace. Okay, this is something we have understood. It's returning a void. And here we can see a label go to 0. So let's see where this label appears. This label appears, oops, maybe let's clear this, over here, 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 and here. Okay, so it appears in every catch block and we end up over here, in this line. This one is the end of the local variable, so this one is being ignored. We start at this point. Nop means no operation. This is absolutely amazing. I haven't encountered this quite a while. So this is simply just do nothing processor. Not sure why it's included over there. But after this nop, we can see this one over here. This is also just a label which can be ignored because we have no jump instruction to this one anymore. And then we write v1 equals 0. So we are writing 0 into v1. And then we are returning out, which means we are returning null. All right, and it doesn't matter in which exception we end. This will be the end over here. So we are having here an exception, here an exception, here an exception, but all come down to this label. Go to 0. Let's do this maybe for another one. Let's see. Here we have catch 3 in this one. Okay, we move exception into v1. All right. Then we've got v1, e print stack trace, and so forth. It's returning void. All right. And then we've got the end of our local variable. And then we've got this go to label, which means we end up over here. So also catch, what was it? Catch 3. So this happens for all exceptions over here. We end up over here and this one is simply just return null. So yeah, this also fits perfectly into our code right now. And this one over here. Let's clear the screen. There we go. Yes, and so we are having return null all the time over here. But Smiley is a little bit more efficient on this one right now. Okay. So this is all for this video right now. This wasn't just picked up because we can understand this. This was a completely random case. For example, switch cases. We haven't talked about switch cases, but the approach is the same. And everything else is just consisting of Smiley instructions. So everything else is just Smiley line after line. The only difference is some weird constructions like this one over here, where we have some jumps, but the rest is simply just we go through this line by line. And with this knowledge, we can understand 95% of Smiley. There might be really some edge cases which we cannot understand right now, but if you encounter them and you're not sure, then simply please just write me a message. I'm glad to help you out on this. Or maybe just by looking them up online, you might be able to solve this on your own. Because with this knowledge you have been wrapped up right now, I'm pretty sure you can do this. Alrighty? Okay, perfect. So this is part 1, which has become another long video, but I guess it's pretty amazing how far we already have achieved. In the next one, we will look at printing out some hard objects. For example, we want to get the initialization vector value out of this one. Or for example, we want to have the secret key to be printed out as a string, because the return type over here is a secret key. So how can we print out the secret key if it's a completely different object? This is something we will figure out in the next video. And afterwards, we will look at another amazing example, which is inserting complex Mali code into an existing application over here. Therefore, I'm really looking forward to see you at part 2.